Hello and welcome to another flipped classroom with me, your host, Mr. Rappell. Today we are going to be looking at the final exercise for this chapter on graphing parabolas, and that is exercise 6D, learning how to graph parabolas that are in the form y equals ax squared plus bx plus c. Now there's a couple of ways that we can actually approach these questions, and if you have your book in front of you, you can follow along with me. Any equation that is in the form y equals ax squared plus bx plus c can be done in these two ways. First of all, you can use the completing the square method that we learnt in the last chapter to turn a parabola or a quadratic into the turning point form that we've discussed in the previous exercise, which is y equals a bracket x minus b bracket squared plus c. However, if you do not wish to use the completing the square method for whatever reason, then to sketch a parabola you must follow the following steps. Okay, so there is about 6 steps, as you can see, and each step has its own unique method of finding the correct solution. For example, number 1, you must first find the x-intercept, which means in your equation you let the value of y equal 0. Now that will make your equation look very similar to the quadratics that we did in the last chapter, and then it is your job to then solve for x, that is finding the x-intercepts. Now to do that, you have to solve using the difference of two squares, the cross method, the quadratic formula. It doesn't matter what you do, you need to solve for x. And remember, in the last chapter I said that the answers that we were getting were the x-intercepts, and that is what you would be doing in that first step, solving the formula. Next step is to find the y-intercept, which is letting x equal 0 in the equation. For that step, it would be relatively easy, and you'll get an answer, which is going to be the letter c in this equation here, the letter c. Right, next step. Check the nature of the turning point by studying the a value. If a is positive, the curve is concave up, which has a minimum turning point. If a is negative, the curve is concave down. We discussed that in exercise 6b and also in 6c. Alright, step number 4. Find the value of the turning point by using the formula x equals minus b over 2a. That is using the letters b and a from this equation over here. Okay, now the other way to do it is to find the average of the x-intercepts. So that means, let's say for example that my x-intercepts for an equation were 2 and 4. That means that the turning point is going to be in the middle of those two values, because remember, a parabola is symmetrical. And what's in the middle of 2 and 4? Well, that's 3. So that means the x value for my turning point is the number 3. Step number 5, find the y value of the turning point by substituting the x value found in the step above into the equation. So hypothetically, if our result was 3, we would then take that number and we would substitute it back into this equation up here. And that would give us a value for y, which we would then use in our turning point in step number 5. Now step number 6 is it's worded a bit funny. It says write the point as a point. Now what it means here is in step 4 and in step 5, you've calculated an x value and a y value for the turning point, and step number 6 is simply collating that information into a point. So let's just say in example number 5 step number 5, that the answer we got was 5. right? So that means that our turning point is 3, 5. So all it's asking you to do is collate the information you got in step 4 and 5 into a point form, writing it as a turning point. Okay, let's have a look at a couple of examples, and I'll show you how to do number 1 using the turning point form, and number 2 using these steps that we've just covered through just now. Alright, let's start example number 1 by completing this question in turning point form. Now remember, to get it to turning point form, we need to remember how to complete the square. Now I'm going to go through the steps pretty quickly. If you need to revise, it may be helpful if you grab your old booklets out and look through the steps on how to complete the square. Okay, so first of all, we're going to start off by substituting 0 in for y to find our x-intercepts. So that means it's going to become x squared plus 12x minus 4 equals 0. Alright, now remember the first step is to add 4 to both sides. So that becomes x squared plus 12x equals 4. Now, we now add a number to both sides, which was half of 12 squared. So half of 12 is 6, and squared is 36. So this will now become x squared plus 12x plus 36, and add it to the other side, becomes 40. Okay, and then to complete the square, we now factorize it to x plus 6 squared, and that equals 40. Right, now remember, turning point form is y equals a bracket x minus b squared plus c. So we need to move the number over here over to the other side. So this equation will finally become x plus 6 squared minus 40 equals 0. Now before we go ahead and put this information on our Cartesian plane, let's move to the next slide and have a look at where our x and y intercepts are going to be. Right, now having a look at our two intercepts, to find the x-intercept, this is where y is equal to 0. Whereas if we're looking for the y-intercept, this is when x is going to equal 0. So let's do the y-intercept first, so the right-hand column. Now you can see already the first step in each column I've done for you. I've substituted the value of 0 in for the appropriate letter. So instead of writing x, I've written 0. Okay, so let's simplify and see what number we get. Right, so 0 plus 6 is just 6. 6 squared is 36. So this becomes 36 minus 40, which is minus 4. So we know that the parabola crosses the y-axis at minus 4. Alright, now the other one is going to be a little bit harder. So let's start rearranging. We'll add 40 to both sides. So we get x plus 6 squared equals 40. And then what we're going to do is take the square root of both sides. So this gives us x plus 6 equals plus or minus the square root of 40. Alright, and our final step is to subtract 6 from both sides so that our final x equals plus or minus the square root of 40, the square root of 40, and then minus 6 at the end. Now that's going to give us two solutions. You'll be very familiar with this from the last chapter, but if we do plus the square root of 40 take 6, that means x is going to equal minus 12.32, and it's going to equal 0.32. So when we get these answers from our previous chapter in quadratics, these answers are actually part of graphing our parabola. And so these answers that we've found here are actually the coordinates where the parabola crosses the x-axis. So this is our x-axis, and this one is our y-axis. Okay, so let's use this information and plot the relevant points on our graph. Okay, so the first thing that we're going to do to this particular graph is we are going to put the turning point in. Remember, the purpose of putting a graph in turning point form right at the beginning of our explanation of this example was to help us get it or identify where that turning point is going to be. So this is telling us that the turning point is going to be 6 units to the left here and 40 units down. Now I've already put a scale on this Cartesian plane. My y-axis up here is going up in units of 10, and my x-axis is going up and down in 3 units per square. So our turning point is going to be at plus 6, so 6 units to the left, and then 40 units down, so it will be going here. Okay, now remembering our information from the previous slide, we know that we have a y-axis at minus 4, which is going to be approximately here on the y-axis. And we know that the x-intercepts are going to be at minus 12.32, which is going to be approximately here. And that the other x-intercept is going to be at 0.32, which is over here, approximately. The last thing that we need to do is draw in our parabola. So we start up here, come down at our turning point, go up through the y-axis and our x-axis. Make sure we label our turning point is minus 6 and 40 and minus 40. And that's about all we can do for this example. So the three things that you need to know in drawing it are your turning point, your two x-intercepts here, and your y-intercept. Last but not least, we could ask you what the axis of symmetry is, which is relevant to our turning point, but for this example it is not required, and so we have successfully completed this example. Alright, now let's have a look at example number 2. Remember, in this example we were going to look at how to solve these questions using those 6 steps that were on the introductory page to this exercise. Okay, with example number 2, the first step that we needed to do was to find the x-intercepts. Now if you have a look at step 1, that means we have to put y is equal to 0 very first up. So x squared minus 12x plus 32 equals 0. Now from here you had a few options. You needed to somehow solve for x by either factorizing, finding the difference between two squares, completing the square, some way of finding out what the value of x is. So, for this particular question, I've already had a look at this previously, and the easiest way to solve this is going to be factorizing. Now with factorizing, we are looking at the factors of 32, which add together to give us minus 12. And it just so happens that these two factors are going to be minus 8 and minus 4. So this factorizes to x minus 8 and x minus 4 equals 0. Now that means that the value of x is going to be either 8 and 4. Okay, so that was step number 1. Step number 2, we had to substitute x equals 0 into the same equation to find out what the y-intercept was. So that means we have an equation y equals 0 squared minus 12 times 0 plus 32, which equals 32. So that is our y-intercept. So far, we've got 2 pieces of information. Now what we need to do is have a look at the value of a, that is the coefficient in front of the x. Now we have a look at that to determine whether it's going to be a concave up or concave down, or in general terms, whether it's going to be a smiley face or a frowny face. So we have a look and we notice that it's just positive 1. That means it is going to be a smiley face. So now we move on to step number 4. And step number 4 is with our turning point. Now there's a couple of ways to do it, remember. We could either do, for step number 3, x equals minus b over 2a, or we could simply find the middle of our 2 x-intercepts. Let's do the minus b over 2a. So minus b is going to be 12 over 2 times a is going to be 2, and so that equals 6. Notice how the number 6 is in the middle of 4 and 8. That is the average of those 2 numbers. So that is the second way that we would have figured this one out. Now to find the y point in our turning point, we need to substitute the value of 6 into our equation, and that will tell us the value of y. So that means we have to do 6 squared minus 12 times 6 plus 32 to give us our answer. Now that is 36 minus 72 plus 32, and that equals minus 4. Okay, now this should be all the information we need. We've got our y turning point and our x turning point, so all together in step number 5, our turning point is 6, minus 4. So we've got our turning point here, we've got our y-intercept, we have our x-intercepts, so now we can draw our graph. Alright, so here is our Cartesian plane. Let's set up our scale. So let's see, our x-intercepts are between positive 4 and positive 8. So let's go up in 2s. So I have 2, 4, 6, 8. So this is 2 and 6. And the same on the other side as well. And then for the y-axis, we're going to, let's see, the y-intercept is 32. So that means we are going to have to go up in, I think we'll go up in 8s. So 8, 16, 24, 32, 40. So 8, 32. Alright, and the same below the x-axis as well. Alright, let's fill in our important details. Starting off with our x-intercepts. We have one at 8, which is about here. And we've got one at 4, which is about here. Our y-intercept is 32, which is up here. And we have our turning point at 6 and minus 4. So 6 is here, minus 4 is going to be about here. Okay, now it's just a simple matter of joining the dots. So here we come, down from here, across the x-axis, hit the turning point, and go back up again. Now again, with this example, we could, in fact, write in 6, comma, minus 4. We could also ask you what the axis of symmetry is, and you should be able to tell us that it is the line that goes down through here, and that line has the equation of x equals 6. Alright, and that brings us to the end of this exercise as well as this chapter. I hope you've enjoyed listening to these videos and learnt a little bit more about parabolas. And if you have any questions, please make sure you come and see me in class tomorrow. As always, I'm Mr. Rappell. You have a good day.